All right, guys. Anybody have questions from homework or anything else? No. Okay. So, what I want to do is this. Let me see. Where do I have this? Here it is. Okay. So, let me throw this up here. All right, so you should see something right now that says GCF and grouping practice. You guys see that? Anybody?
Yes.
Thank you.
Yes.
Thank you. So if you could take a minute and copy down the problems you see, try to start working on them a little bit, and then I'm going to break us out into rooms, and you guys can collaborate, sort of like we did the other day. Yay! So try to do those 5 problems on the screen, and then I'll break you up randomly. Oh, here's somebody else. So if you just joined, if you could please copy down those 5 problems on the screen and give them a try. In a couple minutes, I'm gonna break you guys out into rooms, compare answers, and then we're gonna learn some more new stuff. New stuff? Where have you gone? Oh my God. All right, if you're just joining, oh shoot, you probably see my email, don't you? I don't know anymore what you see. Where'd the thing go?
You just see GCF and grouping practice. That's
Thank the
the one
gods.
that's visible on the screen.
It's not like I have anything amazing in there. I'm trying to double task the. Does everybody have those 5 written down? Hopefully you've gotten a couple of them started. That last one, number 5, is the one that we went over last time. So what I'm going to do, I'll give you just a couple more moments here, and then I'm going to break you guys out into groups. Let me see. Okay, let me break you guys up. Let me see. I'm going to stop sharing. You guys should all have that written down by now. I'm going to break you guys into groups. Let me see. Where is it? There it is. I got 11 people. That's neat. You can break them into 3 groups. All right. Randomly done. Let's see who you get. Here we go. Go to your room. Click on the link to go to that room, guys. I am. Go to the room. Click. Click on the link to go to your room. Thank you. It's just crazy to me. This is you're fucking driving me crazy. Marianne, driving me crazy. I don't know what's going on. Okay. Everybody always, thank you. It kind of shuts off when I do the breakout room. So, and then what you're left with is 4b divided by 4 is b. 12 divided by 4 is 3. Come on. And so, oh, somebody's trying to come back in.
Is it okay to do it differently, or I guess maybe show more work? So in the book it says, so break down each one. So 4b
No, you can
and 12.
totally show more work. That's awesome. I don't, if you think you need help seeing more work for yourself, I'm okay with it. So the book probably says to do something like this.
Well, it says break
Even
it.
more.
So the factors of 4b is 2 times 2 times b.
Yeah.
And then the
yeah.
factors of 12 is 2 times 2 times 3.
I love it.
You circle
And do you
the
see
ones
how,
that are.
yeah, I'm with you. But do you see how that quickly becomes insane? If you want to write all the factors of 80, no, I'm trying to get you to the point where you don't have to do that, right? Is that cool? Because the whole idea here is very straightforward. If I distribute, I give this to both of these. So when I'm going to do that in reverse, I take the same thing out of both. So you have to think, what is the biggest thing that I can take out of both of those? Because it's the exact reverse of giving them both. That's that thing. Okay, maybe. So for example, let's do another one, a little side example. Let's do like, what do you got, Jeff? Yeah, so 8m plus 80. So like I was just saying, right? 8m plus 80. Make less glare. Okay. So what comes out of both of these?
8.
8. And again, this needs to be something you can see relatively quickly. Even if you don't see, even if you're like, okay, a 4 comes out. If you think about 4 first, you can see that more comes out. Take another 2 out, and that makes 8. But hopefully you don't need this middle step, right? It's sort of like reducing fractions in multiple steps because you didn't see the biggest thing to start with. It's the same exact idea. Okay. I like it. So that's the better general idea. So I don't have to try to break everything down because sometimes when they're huge numbers, they're going to be crazy amounts of DNA for that huge ass number. Okay, maybe. So now, if we do the second one, it's got some letters going on now. All right, so you start, so again, like I said last time, start with the numbers. What comes out of both of these numbers?
15.
15.
5.
And 1x.
And then you look at the letters. Yeah, so only 1x can come out of both. He can give 2, but he can only give 1. Let me stop right there. Does anyone have any issues with identifying this guy? That's the guy that somebody must have distributed because they both had these things. They both have a factor of 15, and they both have a factor of x. So we're kind of like undoing what somebody did. So I took the 15 out. I had 2 x's. I took an x, so I got
Just X.
1 left. 30 divided by 15 is
2.
2. And I had an x, and I took it. Bam.
2X.
No x, right? Didn't I take the x out?
No X.
No x. So if I check it, I could very quickly check it. 15x times x is 15x squared. 15x times negative 2 is negative 30x.
It's a lot
So I can
easier
check.
than the way they taught it in the book.
Say again?
So that's a lot easier than the way they taught it in the book.
I agree. So the way they taught it in the book is for students who still have a lot of trouble. I'm going to assume that you all have down the basic idea of breaking numbers down
Professor.
into parts.
Professor.
Sorry?
Number 2. I put 5X, and on the parentheses, I put the 3X minus 6.
Again. So
It's wrong?
it's only wrong because you're not done yet. So if you take a 5 out,
Okay.
there. If you take a 5x out, that's 3, I agree, and that's 6, I agree. I totally agree with you. I totally agree with you. So then you look at me and you go, well, then what the shit's wrong, Jeff? Well, there's still more in there. Oh, now we got a bird. This is awesome. What the hell's going on out there? Isn't there both, they both still have a 3? You see that?
Okay.
Who's got the bird? What's happening?
Okay.
It must be you. You're the only one that's got, okay. So then you could take a 3 out. Stay with me now, you guys. Take a 3 out. 3 times 5 is 15. And I take a 3 out, there's an x, and I take a 3 out, there's a 2. It's the same answer. So now watch. I really want you guys to get this. Do you remember reducing fractions? It wasn't that long ago. We've reduced fractions in this class. Stay with me now. Watch this. Let me take this guy away. We have reduced fractions before in this class. If I said reduce this 48 over 80, Does it really matter if I have to do it in more than one step? Like I can see that an 8 goes in, right? Are you guys with me? An 8 goes in. So if I divide top and bottom by 8, I'll get 6/10. Am I done? No. Oh, okay. So I just do one more step. No big deal. Divide by 2. Jeff, divide by 2, divide by 2. Do you guys see what I'm saying? So if I did this problem and I took a 5x out, that's fine. I just see that I'm not done yet. There's still a factor of 3 that I could take out. Just like over here, there's a factor of 2 I could divide by still. It's exactly the same type of idea. So that's why it's called greatest common factor. You try to take the biggest thing out. And if you don't get it on the first try, just take the other thing out. So let me show you the real way this works. 5x times, I can take a 3 out. And then 5x times 3 is 15x. Bam. Same answer. A couple more steps, but this is the same answer. That's all that matters. All right. When I get 0 reaction, that's actually when I'm most concerned. All right, let me see. Let's try out the third one. The third one's just kind of gross because the letters are kind of similar. Oh, let's see, 36. All right, so your first step is always look at the numbers. And then you look at the letters as they come. So what number comes out of these, obviously, right?
9.
9. Now look at the M's. What's the most M's I could take out?
1 M and 1 N.
Yes, 1 each, because even though this guy could give 2, he can only give 1. And we're trying to be sort of fair, right? We're going to take everything you got, just not more than you got. If I tried to take 2 M's out of him, what the hell would he do? He's only got 1. So I can take 1 M and 1 N. Now you look at this guy. 36 divided by 9.
4.
I had 2 M's. I took 1. 1 left.
I'm
I had
support.
an N and I took it. No N's left. All right. I see questions in your face, but I don't hear questions. Minus 9 divided by 9 is 1. It's gone. I had an M and I took it. And then I had
Minus N.
Minus M.
I had 2 N's and I took 1. I'm with you.
Okay.
Can we again? Thank you. Okay. All right. Now let me show you something. I kind of like to show you, we really need to be okay with numbers to not have to do too many in between steps. But let me show you one thing that will help you.
That one is like we try to get the question, not the answer, right?
Yeah, look at that shit. So it's sort of like somebody did a problem. Somebody multiplied things out. And what we are trying to do is find out what it was. So when I distribute, I give one thing to several other things. They both get the same thing. So when I am doing this GCF, it's undistribution. What do they have in common? That must be what was out here. That is a very good way to look at this. And that's the way I've been trying to say it. So you are developing the question given the answer. Kick ass. I love it. Good. And that is really why factoring is harder than just straight up multiplying, because we're trying to piece back together what it was to begin with. That's not going to be like immediately easy. It's not going to be horribly difficult either.
When we make the question, it's harder.
Yes. Yeah, it is. Of course. Yeah,
Right.
totally. Let me think. What was I going to do? I forgot. Oh, well. All right. So everybody got that one? So what about this guy? Let's see. This one's a little bit longer. All right. So we got 3 terms now. Doesn't matter. The idea doesn't change. Look at all 3 numbers. What comes out of all 3 numbers, of course?
4.
4.
AD squared.
Yeah. You look for the smallest power. There's a single A, and you look for the smallest power. There's 2 D's is the smallest power, because that's what they would all have in common, is whatever the smallest power is. That's the shortcut. I like it. I'm trying to remember, there was something I was going to do. Oh, so now I take each term one at a time. 12 divided by 4 is 3. I had 3 A's. I took 1. So I have 2 left. I had 4 D's. I took 2. So I have 2 left. Oh, that's right. I was going to show you the other. Okay, that's right. I'll do it when this one. All right. I was going to show you something I totally forgot. I'll show you on this one. 24 divided by 4 is 6. I had 2 A's. I took 1. I still got 1 left. I had 5 D's. I took 2. I got 3 left. So I really want you to understand why it works this way. But once you see how to say it to yourself, it's not that bad. It's I have this many. I took this many. I got this many left. And you keep on going.
Plus A.
Yeah. Well, be careful.
Plus A.
Took the
Plus
4,
1.
Took the A. Took both D's. So some people think there's like 0 left. But what is
Plus
something?
1.
Yes. Something
Plus 1.
divided by itself is 1.
Plus 1.
I like it. Okay, now watch. That problem is done, right? So if you're having any issues with this, the one step in this you have to be able to do is this one, for sure, is figuring out what can come out. What's the biggest thing that goes into everything? But here's a little something, and I'm not saying any of you are going to need this. I'd love it if, I don't actually care if you need it or not. But hopefully you get to the point where you don't need it. Here, let me show it to you so you can at least make a decision. I've lost all my markers. All right, I'll survive. My whole house is moving. Okay, so let me show you this. It's kind of neat. So if you figure this out, and when you distribute, what are you doing? Multiplying. So when you undistribute, you are dividing, right? So if you need to, once you figure this out, you could put each thing, get it right, John, over that. Right, so minus 24a squared d5 over that. Plus 4a d squared over that. Because that's really what's, well, let's see. That's really what we're doing. I personally don't like to teach this first because I want you to not need it. But if you need it, that's fine. Figure out what comes out. And what do you do when you're taking stuff out? You're doing the opposite from what you do when you put it in. And when you put it in, you're multiplying. So when you take it out, you're dividing. So you can actually just write it. Let's see what we get. 12 divided by 4. 1a cancels. 2d's cancel. Same thing. Keep going. You'll get all the same stuff, right? So if you need it, you can do this for yourself. All right, you really got to a good point where you don't need this. But if you need it for now, that's fine. Hopefully you'll start to get motivated to see some shortcuts, because that gets a little tiring writing all that stuff out. Okay, maybe. So let's try this last one out. So you got that stuff? Okay. So that is an option. I'm hoping you guys see the idea of, it's just almost too nice to believe. 3 A's, I took an A, I got 2 left. That's just so nice too nice to be true, but it is. Ha. So what about this last guy? This is the last one we did last time. So let me first ask you, how many terms are up there?
2.
There are 2 terms. I love it. 1, 2. This term has an x and a y minus 2. This term has a 3 and a y minus 2. So of course, what do they both have in common?
Y minus 2.
Yeah, they both have a y minus 2. So if I take y minus 2 out, you're left with an x and a plus 3. That's the part that's kind of difficult for people to get. But remember, y minus 2 is one thing. Y minus 2 is one thing. If y is 6, it's the number 4. It represents one unknown quantity. So if they both have that same unknown, you can take it out. How do you check this? Y minus 2 times x, bam. Y minus 2 times 3, bam. Check. So let's take that to the next level. There's always a whole nother level. Here we go. How about if I had this here? What you got, Jeff? All right, now this one, you should notice we're going to have to come up with a different approach because does GCF work? Can you guys see? I have 4 terms up there, right? Is there anything that all 4 terms have?
Yes, x minus 4.
Oh, Youngsha, all right, that's awesome. That's awesome, but you're a little too advanced. Just hold that back. Not all of us, we can't really see an x minus 4 directly yet. You can, that's awesome. So just love that. Let's all catch up to her, right? Is there anything that comes out of all 4
Two
terms?
groups.
Nothing.
Separate them.
Yeah, we're going to do that, but we haven't talked about it yet. So let me talk about it first. I just want to make sure you guys can see why we need a new way to do this. Because the only thing I know so far is GCF, and it ain't going to do shit for me. Because nothing is the same in all 4 things. You guys with me? So what we do in that case, in fact, I'll say it like this. If you have 4 or more terms, and GCF, you can do it or not, you try, like Youngsha said, you try what's called grouping. You put these 2 together and these 2 together. So you kind of make 2 little GCF problems. So if you have 4 or more terms, you try what's called grouping. So if you look at this little group right here, just these 2 by themselves, what comes out of both of those? What comes out of these 2?
Y.
Y. And what's left?
X minus 4.
Yeah, x minus 4. I like it. Kick ass. Plus, what comes out of these 2?
X.
X. And what are you left with?
4. X minus 4.
Yes, x minus 4. Mom! So do you see how now it looks just like the one we just did? Now I've got 2 terms, and those 2 terms have this in common, right? If these were not the same, the whole thing is crap. You can't do it. You might have to actually change the order of some things up here. But watch. What comes out of these 2 things, of course, is the x minus 4. And then what am I left with? Y plus x. All right. I could tell you guys like that one a lot. So that was a one step, and then all of a sudden it looks the same as before. So when you have 4 or more terms, you try grouping. You can see why we call it grouping. There's a group, there's a group. There's some GCF groups, right?
There's 2 Y's in the first now new grouped term. Do you not, you pulled 1 out in that first? Do you not?
Do you think that's a Y? Or what's that?
No. You have Y in parentheses X minus 4 right above that. But
Yes.
there's 2 Y's in the first grouping term, but you only pulled 1.
No, there isn't. No, there isn't. Because what would I do to simplify this? When I distribute it?
Yeah.
So then that's why there's more than one Y. Because that Y gets distributed to both.
Okay.
I like it. So there isn't more than one Y. There's one Y that was distributed to both. That's what we've been doing, right? I like it. Okay, maybe. All right. Now let me push this a little bit. That problem is completely done, right? The problem is completely done, but I'm going to do a little extra something weird to it, okay? Like I do sometimes. And I wish I had my other markers, but they have, oh, there's one. Let's see what this looks like. What are X and Y? Numbers I don't know, right? So give me a number for X. What could X be?
4.
I don't hear it. Let's say 7. What about Y? Anybody? What do you want Y to be? They could be anything we want.
2.
Right? 2? Okay.
You still have any number?
I was in a Zoom meeting where this one guy was like this the whole time. And then, sorry. You guys, am I with me? Where did I get 7 and 2? I got 7 from me, and I got 2 from her. You could have said anything. All right. I'm doing extra shit. You're never going to have to do what I'm about to do, ever. But I want to show you what's going on. If X is 7 and Y is 2, what's X times Y? We're going to evaluate this now that we've given these numbers, right? What's X times Y if X is 7 and Y is 2?
14.
X is 7, Y is 2. What is X times Y?
14.
14. I see it. Okay, thank you. Right? 7 times 2. What's 4 times Y? 4 times 2 is 8. What's X squared? 7 squared is 49. And what's 4 times X? 4 times 7 is 28. So what number is this? This whole thing is a number. If I just knew what X and Y were, right? That's what every variable expression is. It's a number. If I just knew all the variables, it would be a number. So if I know what X and Y are, it's a number. What number is this? 6 plus 21 is 27. If you guys don't trust me, you can do it yourself. I really want you guys with me on this. I could have made X and Y anything. Anything. I could have made X square root of 7. I don't want to do that. But so we picked 7 and 2. Why the shit not? They're not crazy numbers. They're fine. Right? So if X was 7 and Y is 2, this is the number 27. It is the number 27. What is this? What was X again? 7. So what's 7 minus 4? If X is 7, what's 7 minus 4?
3.
3.
Times, and what's Y plus X?
9.
9. Is that a way to factor that? Can you factor 27 as 3 times 9? Yes. Yes. I don't know. Some of you guys, I am almost certain some of you guys are out there going, all right, I don't know. I don't even know. Anytime you have a variable expression, it is a number. If I just knew what all the variables were. So if I assign the variables numbers, whatever I just did with the expression has to be true about the number. That's kind of neat. You can make X and Y whatever you want to. And if you don't believe me, try it. Whatever number this comes out to be will factor like this. Right? So why is this so hard then? Because we're factoring, how many numbers are we factoring? How many numbers did we factor when we did this? An infinite number. Do you guys understand that? Because what could X and Y be? Anything. So why is this so hard? Because we're factoring an infinite. So in that case, if you think about that, that's easy. If I said, hey, factor an infinite number of numbers for me, you look at me like, no. But we just did. Ah, all right, sorry. Hopeful. All right, so the whole thing I just talked about in all the red writing, everything there is extra shit, right?
Can you put in the up a little bit?
Sorry?
Okay, the number, direct numbers now. Yeah, thank you. Yes.
Can we do another one, but without the numbers?
Yes. All right, let me make another problem. I won't do the weird red stuff again, okay? I just want to show you that at least once. At least once. Everybody all right? Okay. All right. Bum, bum, bum. Okay, get over here. So let's try this one. Let's see what you got, Jeff. Oh yeah, let's do one like this. I like it. I guess it has to work, huh? Working would be good, wouldn't it? Yeah. Minus one. All right, let's see. Yeah, that'll work nice. I like it. All right, let's try this out. First thing you always try. The very first thing you always try, no matter what, is GCF. Is there anything that goes into everything? Do they all have an A? No. Do they all have a certain number? No. Do they all have a B? No. Do you guys see that? So first thing you always try is GCF. We're going to learn 3 more factoring methods, and they're all going to be dependent on how many terms you see. That kind of kicks ass. So right now we know this. If I see 4 or more terms, I try grouping. So if you put these together and these together, what comes out of these 2? What number comes out of these 2?
7.
7. And what letter comes out?
B.
B. So 14 divided by 7 is 2. The A is still here, and I took the B minus, what's 7B divided by 7B? That's right, kids. Kayla's having some issues. You doing all right? All right.
Do we take 7 out because 7 goes into 14?
Yeah, of course. So you always want to take out the biggest thing, in that case a number, that goes into everything. Right, so 7 goes into 14 and 7. That's why we took it out. What about over here? Now here's where you got to be careful. I want you, so the thing about grouping is, I'm going to get another little dude over here, aren't I? That's the whole point. I'm going to get some other little thing left over. It has to be this. Whatever's here has to be this. Otherwise, we can't do the last step. That's kind of nice. It's not extra crap to memorize. It actually helps you. I know there's supposed to be a 2A here. So you can kind of keep that in mind. What goes into both of these?
3A.
3A?
3A, but you're not quite right.
And 2A.
Negative 3A.
Yes.
Because see, then that would change the sign and make it positive the way it's supposed to be, right? So it's 6 divided by negative 6 divided by negative 3 is 2. Add
2A
2a, subtract 1 left. What's 3a divided by
plus
6? -1. All right, let me stop for a minute. How do I know I'm on the right track? How do I know I haven't made a mistake? These are the same. Knowing that really is awesome. If you feel pretty good about what you did here, you can use it as a guide for what's supposed to show up there, right? Now, so now that they're the same, what's my last step? What can I do? What can I take out? What do both of these things have? What's the same in both?
2a minus 1.
2a minus 1. And what's left? 7b minus 3a. What's that, guys? All right, sorry. Woo! All right, so here we go. What's this one look like? Yeah, there's 2 right there. I like it. So here we go. Oh boy, I want you to try these out. Does anybody still need that? I'm going to share my screen. What time we got? Oh, we got time. I like it. All right, do you guys see 6 and 7? Anybody?
yes.
Thank you. I don't trust it anymore. Let me see. All right, so try those out. Give 6 and 7 a try. All right, so in a minute, I'm going to break you guys out again. You should still be able to see that, right? Yeah. How many people do I have here now? 13, okay. Does everybody have both of those problems written down? Anybody still needs that up there? I'm going to take it away.
Hey, hold on. Okay, you can take it away.
All right. Nice. I don't know. Let's see. That would be bad. All right, I'm going to break you guys up. Here we go. Hopefully this works. All right, here we go. Go to your room. Go to your room now. Okay. Mia, Jamie, whoever galaxy has 7 edges, you got to put your name in there sometime. Jamie and Galaxy, please go to the room. Alex is in there all alone. Hey, Alex. I don't know. I'm not sure what's happening. Jamie?
Yeah, I was just alone. Yeah.
And Galaxy and Alex, you guys can go to the room now, right? Go to the room.
Join the room.
Join the room, yeah. Everybody. I'm not sure what happened. Maybe Jamie and Galaxy have stepped away. I don't know. Jamie? Hello? Jamie? All right. There we go. We got everything back. Let me see. Yeah, everyone made it back. I lost a couple people in there. That's awesome. Let me see. So let's do this real quick. The last one is a little tricky.
The first one for me is
First one's tricky. Let's see.
that, yeah, number 6. I confused with it.
All right, so let's see. All right, let's see. Hopefully it's not because of some mistake I made. Oh, it probably is because of some mistake I made. Nope, I put a cube there. There you go. Okay. So sure enough, nothing comes out of everything, right? So I have to break it up into groups. There's 4 terms, so I try to break it up into groups. What comes out of these 2?
1T?
Oh, that it is a mistake. Okay, yeah, a T comes out. And that's it, right? So then I have 4A, I lost a T, minus 3, and he lost his T. Aw.
Okay, that's why.
Plus,
I have to put the number out.
yes.
That's why.
And then here, what comes out of both of these?
Okay.
3?
3, and then I can take a
B?
B. 12 divided by 3 is 4. The A is still there, lost the B. The T is still there. Minus 9 divided by 3 is 3, and I lost the B. And thankfully, these are the same. I like it. So if they're not the same, more than likely you made a mistake, but it is possible that it's prime. Remember those? Numbers you cannot factor are called prime numbers. So it's not impossible for it to be prime. So now since these are the same, I can take them out and I'm left with t plus 3b. I like it. All right. So I'm going to take that one away. So everybody got that? See people writing away furiously. Let's see. Okay. All right, last one for today. Let's see. There's two kind of ways to do this. Let me see. I'm going to go based on the first thing somebody says. Both ways will work. So what's the first thing that somebody did? Anybody? Anybody have a suggestion on what to do?
2x3? 2x2.
Be a lot more specific. What do you mean?
And take out 2x first.
Take out a 2x from the whole thing. I like it. Yes.
Yeah.
Right? So every one of them can have a 2 come out, and every one of them has an x. So I can take a 2x out. So then I'm left with, the 2's gone, I'm left with 3 x's, 5, left with a couple of x's, 2, left with 1 x there, 10, and I took his x. Then, now what can I do on the inside? See, I'm not done. This guy's done. He just comes for the ride. What do I do inside here? I can group, can't I? And you could have grouped from the very beginning. That would have worked. It's just at the end you got to take a 2x out. So what can I take out of these two? How many x's?
2.
Yep. And so I'm left with 1 there, minus 5. And then what's got to come out of here to make it become x minus 5? I can take a 2, but what kind of 2?
-2.
And that'll change the sign, so it'll be the same as this. -2 divided by -2 is +1. 10 divided by -2 is -5. And sure enough, these are the same now. See him? He's just coming for the ride. He's done. He's just kind of coming for the ride. What happens in here? I can take an x minus 5 out. And then what's left? X squared minus 2. Woo! Woohoo! Ah! So eventually, when we learn all the different forms of factoring, I'm going to put up a handout that's a review of all the forms, how they work, and how to tell when to use which one. That will help you with your homework.
Which section in 7 point, what would this be?
7-1. I like it. Let me see. Oh, I had the book open earlier, but yeah, this is 7-1. 7-1 is GCF and grouping. And 7-2 is where we start to, so this is for 4 terms, right? So 7-2, we look at 3 terms. I think 7-3 is also 3 terms. And then we finally look to do, what do we do when there's only 2 terms? So if there's 4 terms, you do something. If there's 3 terms, you do something else. If there's 2 terms, you do something else. So it's kind of nice, is my hope. And just to let you know, if you let x be some number, this will be something, and this will be a way to factor it, just like we did before. That's actually a way to check your work if you had the time. All right. Well, now I'm kind of over. Anybody want to hang out for a minute? Anybody have questions? Are y'all done? You can head out. You can peace out. You can be done. I am so fine with that. You don't even know. But if you have questions, let me know.
Yeah.
So if we
time is
complete,
it?
go ahead.
Hi. What time you gonna make up the quiz?
Oh, for you, you need that makeup quiz. As soon as I get it made, I'll let you know.
Please. Thank you.
Okay.
So if we do 7.1, we're caught up. We'll be going over 7.2 on Monday. Is that
Yes,
correct?
I love it.
Okay.
So if
Thank
you can
you.
get a little ahead, that's fantastic. But otherwise, you're right on track.
Thank you.
Kick ass. All right, guys.
Bye bye.
See you.
Have a good weekend.
I will.